Okay. For number 1, Larry, what's the antiderivative of 3?
3x.
3x, because the derivative of 3x is 3. Abram, number 2, antiderivative of negative 17.
Negative 17x.
Because the derivative of negative 17x is negative 17. The antiderivative of x, Austin.
1/2 x squared.
1/2 x squared. Because when you do the power rule with 1/2 x squared, the 2 times 1/2 goes to 1, we're left with x. Antiderivative of x squared, Logan. Number 4.
1/3 x.
1/3 x cubed, because when you do the power rule, the 3 times 1/3 cancel out, and you're left with x squared. How do you guys feel about 1 through 4?
Easy peasy.
Lemon squeezy. All right, let's keep going. Number 5, Q. What's the antiderivative of x cubed?
1/4 x to the 4th.
Okay, because the derivative of 1/4 x to the 4th is x cubed. Josie, antiderivative of x to the 4th. 1/5 x to the 5th. Yeah, you said it right. 1/5 x to the 5th. The derivative of 1/5 x to the 5th is x to the 4th. Very good. Cole, antiderivative of x to the 27th.
X to the 27. 1/28 x to the 20.
When we take the derivative of 1/28 x to the 28th, we get x to the 27th. Antiderivative of 1/2. Trevor.
2/3 x to the 3/2.
2/3 x to the 3/2. If we do the power rule with 2/3 x to the 3/2, do we end up with x to the 1/2? Was that tricky, or was that like not a problem to think about? I want your opinion.
Well, that got really hard at number 11.
Okay, number 11 is where you had issues, not this one? Okay.
Your number, sorry,
Michael, number 9. What's the antiderivative of x to the negative 4/3?
5x to the 1/5.
5x to the 1/5? Okay, because when we take the derivative of 5x to the 1/5, we get x to the negative 4/3. Okay? All right. Antiderivative of sine to the 5x. This is where it got tricky?
Yes.
Okay. Alex says, what did you get, Alex?
Negative 1/5 cosine of 5x.
Negative 1/5 cosine of 5x. We have to account for that chain rule a little bit, right? Which is why we have the 1/5 on the outside. And since the derivative of cosine is negative sine, then the antiderivative of sine has to be negative cosine.
I'm good with this.
Okay, number 11. Hey, Gina, what do you have for number 11?
What are the pi sine
That's right.
Why did you guys tell us we did the chain rule?
Okay, because we have a constant multiplied inside, we have to account for that chain rule. So we have to think about 1 over that number, so that if we were to take the derivative, the chain rule would cancel out that constant. Okay.
Very good, bro. Very good.
All right, and then number 12. Jake, what do you have?
3/5 x to the 5th is 1/4 x to the 3rd.
3/5 x to the 5th plus 1/3 x to the 3rd. Do you agree with Jake? Thumbs up if you agree with Jake.
Close to number 1 because the truth.
Okay. So, you basically have figured out a couple basic rules for antiderivatives. Okay? Let's talk about what an antiderivative is.
True. Okay, that sounds like something.
It's not a proof.
Are we gonna need our, yeah.
Are we gonna need what? I am gonna give you a few notes, so if you need your notebook, you can take the time that it's gonna take us to open to get that out.
Do you think we could fit it on this yellow sheet or no?
Potentially, like in that second column, like make a column.
Yeah.
Yeah, because it's just this right here. These are our notes. All right, so capital F is an antiderivative of F if the derivative of our antiderivative is the function. Okay, now I need to introduce you to some notation. So first, let's just, wrap our head around the idea that the antiderivative of a function is a function that we would have to derive to get the function. Okay. So taking the derivative of an antiderivative gets us to square one. Okay. Okay. Here's our new notation. This is an integral symbol, and it means take the antiderivative. Okay, and this dx right here tells you with which variable to take the antiderivative with respect to. Kind of like we have dy dx for our derivatives, tells us to take the derivative with respect to x. That dx in our integral tells us what to take the antiderivative with respect to. Okay? Now, I have a question for you. What's the derivative of a constant?
0.
Thank you. It is 0. So anytime we take an antiderivative, okay, we are going to have to account for that there could be some constant added to the end of it that we don't know because the derivative of a constant is 0. Later on, there will be ways in certain cases to find this plus c, but for now, we just know that it could be some function plus a constant. Okay. Let's also understand the fact that an antiderivative and a derivative kind of undo each other. Right? That's kind of basically what you were practicing on this activity sheet I had you do. So, like if we have the antiderivative of a derivative, we're going to be left with the function. Okay? Or if we have the derivative of an antiderivative, then we're going to be left with the function. It's like a long skinny S.
Yeah.
You'll get a lot of practice right. All right, so today and on Monday, we're going to go through just some of the basic rules for anti-differentiation. Okay, you'll get a worksheet today that won't be very long. Okay, and then you'll get a half of a worksheet and half of a book assignment on Monday. Okay, and then there will be probably one question on your entire final that will deal with a very simple antiderivative. And then when we get back from winter break, we'll really dive into the chapter. Okay. So. What's the derivative of a constant? 0. So that means if you have the antiderivative of 0 is any constant c. C is just going to stand for constant. Okay? So that's 0 dx. Okay. Okay. If I asked you to take the derivative of kx plus c, you would tell me what? What's the derivative of kx plus c, Isaac Warner? Derivative. What did you say?
K.
You said K? And you feel good about K? Okay. Therefore, if we have the antiderivative of some number, its antiderivative is kx plus a constant. That is what you basically figured out in number 1 and 2 on that sheet. Right? Okay. And lastly today, what rule am I trying to get us to talk about here? Okay, what's that called? Power rule. Okay, so here is your power rule for anti-differentiating. If you have x to some power and you're trying to find the antiderivative, what did you do with the exponent? We added one. Very good, Joe. And then what did you do? Look at numbers like 3, 4, 5, 6.
The reciprocal of the
Okay, the reciprocal of that power to account for the power rule. Okay, and then of course Fluffy.
So that's a way of writing what we did here. That's just a rule for it.
That is generalizing the rule that you basically figured out, right?
I just wrote it.
Oh, I corrected.
Well, I already had like just to include the coefficient.
Okay.
Put 8.
Oh yeah, and that's
well,
fine. Yep, and
on
that's
the
fine.
n plus 1 to the first power.
Yeah, that works. All right, 3 examples. Are you ready? Okay, so using the antiderivative power rule, we have 2 times x to the 4th. So the 2 stays there. X to the 4th becomes x to the 5th. We increase the power, and then we have to divide by the power. Antiderivative of x cubed, Gina, what is it? 3 over 4 x to the fourth?
Oh,
Can you tell me where you got the 3? Excellent. Okay. And then don't forget, we could have some plus constant. The constant could be 0, the constant could be 5 million. We don't know. There's quite a bit of talking and we're not quite done yet. Okay? Josie?
When writing like the answers, will we always have to write that C like on test answers?
Yes, you will. If you forget that plus C, you will. Okay? All right. Can we take the antiderivative right now for that second example? Okay, it would be a good idea to rewrite it so that we have x to a power before using the antiderivative power rule. Okay, so we have x. Remember, we're going to increase our power by 1. Negative 2/3 plus 1 is 1/3. And then we have to multiply by 1 over that power. Or I just like to take the reciprocal. It saves a little bit of time. Okay. So our antiderivative is 3x to the 1/3 plus c. Okay, last example. If your integral is not written, remember this is an integral, if it is not written as x to a power, then we cannot use the rule that we've been using. Okay? So, as you say here, how do we rewrite this? You're not sure? Cubed root of x means the same as what? Okay, so we have x squared times x to the 1/3. And so then what can we do with those? What can we do with exponents if we're multiplying? We can just add them together. So this becomes x to the 7/3 dx. Okay. Cole Smith.
sorry.
So if we want the antiderivative and we have x to a power, we are going to increase the power by 1 and then, like you said, multiply by its reciprocal. Okay? You should always know if you have the correct answer, because if you take the derivative of your answer, you should be able to get back to what is inside.
How did you get 7 thirds?
Since we are multiplying, we can add our exponents, and 2 plus 1/3 would be 7/3. We have 6/3 plus 1/3. All right. I get to give you one of my favorite worksheets of all time. It's just my favorite.
Why? Oh, is it that Haskell's triangle we were doing?
No, that's what we call it.
Okay. Oh, is it Christmas thing?
It is Christmas
It's a
themed.
riddle! What does the riddle mean this, Logan? Let's just Google everything.
What did you say, Logan? Well, then your wish has come true. Oh. I thought you meant right now.